Hi everyone, I thought that I would create a video about string formatting because it's always a challenging subject and some people have been having difficulty with it, so give this a listen slash watch if you would like to hear some of the extra stuff I might have said, if you had been in class or if there had been a class where we were doing this presentation on strings. So I'm just going to switch over to PowerPoint here and we're going to talk about string formatting. So string formatting involves the use of special things called format specifiers, and they're character sequences that are inside strings, and they're meant to be replaced by other strings or floats or integers, as the case may be. Look at this assignment example. Here we're creating a variable called fname, and we're giving it the value of Billy. Fname is like first name. And we can print out the value of fname inside a formatted string using what you're seeing on the screen right now. So we have hello %s, that's in a string with quotes around it, and then %, and then the name of a variable. Okay, that produces the output, hello Billy. Okay, the format specifier is the %s right here, and basically it's like a placeholder, and what Python does is it says, oh, I am going to print out a string at this location, and what's going to be the value of this string I'm going to print out? It looks ahead in the print statement, it sees the variable, it finds out what is inside the variable, what value is stored inside the variable, and it replaces the %s with that. So far, this is not a big advantage to us. We already can do essentially the same thing, but we'll see as we go on that format specifiers give you, once we add in some extra pieces of the puzzle, they give you a lot of control over how stuff will appear. Here's another variable, lname equals Bilson, lname standing for last name, okay? And what I'm showing you right here is that we can have more than one variable and more than one format specifier inside our print string. So in this case, the first %s right here gets replaced by this first variable, and this second %s gets replaced by this second variable. There's the output. As you can see, there's a space between the two %s's, and it's matched by a space between the two the two values of the variables that are output. The format specifiers are like placeholders, and they're replaced by the variables that are inside the brackets, inside these brackets right here and here. This thing inside the brackets, by the way, the fname comma lname, that's called a tuple. The order of the variables that are in the tuple controls the order in which they appear in the string. So here I have switched the order of the variables. So now lname is first and fname is second, and Python prints out Bilson and then Billy. Python doesn't know that Bilson's meant to be a last name, neither does it know that Billy is meant to be a first name. Okay, it doesn't know that fname means first name. It's just a sequence of characters to Python that represents a variable, and it'll print them out and put them out in whatever order you desire. The items that are in the tuple don't necessarily have to be variables. So here, instead of fname and lname, I've replaced them with a string, Mr., and a second string, Mac. So the first %s gets replaced by the Mr., the second %s gets replaced by Mac. So they don't have to be variables. They can be literal strings or literal values of any kind. They almost always are variables, though. And there are format specifiers for integers. So in this example, we have a variable age. It's set to 1052. And our output statement is %s is %d years old. The first %s is going to be replaced with Mr., the second one with Mac, and the %d will be replaced by whatever's stored in age. Can you pause the video for a second and predict what output will be produced when this line executes? If you said Mr. Mac is 1052 years old, then that's right. This Mr. is the first %s, which is this Mr. right here. The Mac is the second %s, which is Mac right there. And the 1052 is the %d, which was replaced by whatever was stored inside age. So for integers, we use %d. And there are format specifiers for float and decimal values as well. Okay, so here we have a variable called discount. It's set to the value of 1052.97 times this very small decimal right here, 0.094538. Okay? If we go ahead now and use what's stored in discount with the %F format specifier to represent a float value, then we'll see this output. Discount, there it is, discount colon space, that's why we see discount colon space, a dollar sign, there's a dollar sign, and the %F is all of this stuff. That's what is inside discount, 99.545678. But since this is meant to represent money, 2 decimal places would be better, and we can do it like this. We just change our output string so it's discount colon space dollar sign as usual. There's our %, but instead of %F, we have %.2F or .2F. The %F, the format specifier, will still be replaced by discount, but now discount will be formatted so that it has exactly 2 decimal places. So we see discount 99.55. I'm missing the colon here. That's a typo on my part. But 99.55. Notice that 99.545678 has been rounded up correctly to 99.55. So this will also do rounding for you. This is one of the most powerful things about format specifiers, okay? String formatting using format specifiers. And this is the fact that we can add padding or spacing to a string. In this example, we're printing this string, an X, a %20s, followed by another X. The %20s will be replaced by whatever is stored in fname, plus something else. We see this on the screen. This X right here is that first X. It's just there so you can see the start of the output string. And this X at the end is this second X right here at the end of the string. I just want to show you the boundaries of the string here. What Python has done is it's put whatever's stored in fname, which was Billy, 5 characters long, and it's added in enough spaces so that the whole distance from the left to the right is 20 characters long. If Billy had been 8 characters long, it would have added in 12 spaces. If fname had been 15 characters long, it would have added in 5. It dynamically adjusts the spacing so that the total length is at least 20. So Python adds enough spaces to make fname be 20 characters wide, and the X's are there only to show the start and end of the string. So fname right now is right justified. That means that the value, the string, is appearing on the right-hand side of the output, okay? But oftentimes we want the string to be on the left-hand side and for the spaces to be after the string, okay? In that case, we use a minus sign. So you'll notice that the difference between these two strings, that we have a minus sign in here, it's exactly the same otherwise. And what that does is it adds in the padding or the spaces afterwards. So if we do this for multiple statements with multiple different fnames of different lengths, we can be sure that the next thing that we print will always start at the same spot. That's useful for the exercise that we have coming up. Suppose our string is stored in a variable called s. Then if we call the strip method on the string s, so we can just add this part right here onto the end of our string, what it's going to do is give us a copy of s, and it's going to have any leading or trailing white space removed. And white spaces like tabs or new lines or spaces. So this would, if the user had typed in some tabs in their input, we would get rid of that, any leading or trailing white space. Okay? lstrip is the same as strip, except that only the leading white space on the left-hand side is removed, and rstrip is the same as strip, except only the trailing white space on the right-hand side, that's why it's rstrip, is removed. These two functions are really useful, s.lower and s.upper. They convert the string to its uppercase form and lowercase form respectively. So if I print name.upper, I'll get a copy of name in uppercase. Name itself will not be changed. So if I were just to print out name in the next line, I would get whatever capitalization was in there to begin with. But name.upper gives me a copy of name in uppercase. Okay? Name.lower does the same thing but converts it to lowercase. This is pretty useful if you want to use it for input validation. You could take your user input, convert it all to uppercase, and then compare the result of that input, that converted to uppercase, to what you're looking for. What this does is it removes or it erodes or it washes out any capitalization errors in the user input. Here's an example. I have a variable called valid input. I set it to be false. I have a loop. It says while not valid input. In other words, while it's not the case that valid input is true, that is the case right now because valid input is false. So while it's not the case that valid input is true, prompt the user to whether they want to exit, tell them they should enter yes or no. Whatever they enter will be stored in result. Then we say if the result converted to lowercase equals yes, or the result converted to lowercase equals no, then we will set valid input to be true. We will know that we get either a yes or a no from the user, in which case that's the kind of answer. Those are one of the two valid choices that we want. We will know that we have got that in this case. Even if the user types in capital Y, lowercase e, uppercase s, or capital N, lowercase o, we will still get a valid comparison because obviously if they type capital N, lowercase o, they mean no. And that's a good interpretation for us to make. If, on the other hand, they don't give us either a yes or a no, then we're going to put an error message saying that they must answer either yes or no, and we'll come back up to the top of the loop and prompt them a second time. When they do give us a valid yes or no, we set valid input to be true, and that kicks us out of this while not loop. So here are your two exercises. Okay, you're going to ask the user for 5 first and 5 last names. That is going to give you 10 variables altogether, right? 2 for each combination of first and last name. Then I want you to use string formatting to print out the first and last names, 1 per line, so that the last names are all lined up underneath each other. So I would imagine here you're going to have 2% S's, right? 1 to represent the F name and 1 to represent the L name, okay? So the first name and the last name. And you're going to use string formatting to add on enough spaces after the first name so that the second name starts in the same spot. If you have enough spaces, they will all, say it's 20, these will all start in the same place at the 20th column in your line. In the next exercise, you're going to ask the user for 5 strings. Okay, so just 5 variables, each one is a string. You will use the stuff from this presentation to convert the strings to uppercase and get rid of any leading or trailing white space. Then you're going to print all 5 strings left justified inside a box of asterisks. So your top of the box will be just a row of asterisks, and the bottom of the box will be just a row of asterisks. The strings in the middle will have an asterisk at the beginning and at the end, and we want those asterisks to line up so that they make a nice neat box. Okay, I'm going to post an example output with this exercise. If I didn't already, I'm going to make sure that I add it in, and you'll be able to see what the output should look like. So that's it for the moment. If you have any questions, send me an email, and I'll get back to you as soon as I can. Thanks for watching.